We have seen that the main purpose of the motherboard is to connect the CPU with other components like the memory and the input-output components. But to do that, to control to control the memory and to control the different components, motherboards use a very specialized software called the firmware. This software is stored in some chips in the motherboard. Usually they are read-only memory, but modern motherboards they are erasable. You can reprogram the firmware of the motherboard, and this firmware controls at low level how the motherboard access to the input-output devices, to the memory, to the components, different components. But to the operating system, uh, don't that doesn't interact directly with the firmware. There is a standard here, the UEFI, that provides an interface between each motherboard firmware that is different and the operating system. So the operating system can access all the motherboards in the same way. This is the UEFI. Another important another important thing that the UEFI does is to boot the computer. Okay, it provides the boot process. We will see this in more detail in a moment, and allows the computer to run the operating system in the first place. So, for example, it was done before by the BIOS, but modern computer don't use BIOS anymore. So, for example, this is a screenshot of a UEFI of a computer, and you here you can it depends on the motherboard. Each motherboard can have a different BIOS with different characteristics and different things that you can configure. So for example, one thing that is usually common to all motherboards is the boot priorities. You configure here where do you want to boot from, but here you have a lot of different things. For example, the numlock keyboard, do you want it enabled when you start or not? Or you can, for example, enable or disable some virtualization technologies on the chip, or configure maybe in the memory you can, in some motherboards you can change the speed of the memory for overclocking or something like that. For example, I have another example here that you can configure the wake up LAN. For example, you can boot the computer for the LAN. You can enable, disable it. Some things about the graphics. So each motherboard can configure different aspects of its own system and of the chips. That's one of the main purpose. The other is the boot process. The boot process of a computer is something like this. This is the old one, the BIOS. But when a computer is powered on, it makes some self checks to say to check that everything is working okay. You have memory, you have all the components the computer needs to run, and then you start the boot, the UEFI boot. This loads a bootloader. It's a small program that is stored. This is dependent on the operating system. So you configure in the UEFI where is the bootloader located. We will see it later in later units when we talk about operating system. And then the bootloader loads the kernel, the main part of the operating system, and then you can run the operating system. But this is done by the motherboard. You need to when the computer starts, it runs a set of instructions stored in the firmware that are prepared to check for some files, configure in the UEFI configuration screen, and then this is provided by the operating system, and it continues and loads the operating system in memory. This is the old system. The BIOS boot is similar, but in this case, there is an intermediate process because you can have here big loaders, but here you only had, I think it was 512 bits for a loader, so the BIOS loaded a single sector on the disk, and then it loaded the bootloader and then the kernel and the operating system. But these two steps are today are integrated here. So you are not seeing this anymore. You will be booting UEFI computers most of the time.